Today we'll be taking a look at how to program our Apex 65 axis head using our optional IGEMS package. We'll look at some of the nuances with the programming, such as placement of leads and programming the height setter that was just shown in this video here. If you're interested in testing out IGEMS, you can go to igems.se, as I've got up here, and you can scroll down to the bottom here. There's a link to download a trial version. You can test it out. So let's go ahead and take a look at IGEMS package. I've got that open here. Main screen that comes up is for 2D, so if you want to do anything 2D wise, you can do it in here, either drawing things or bringing in DXF files or using the parametric shape library and such. So we're going to focus on 3D files today. So to open up any 3D file on the Cam tab, you want to click on this 3D 5x button and brings you into this 3D world. So this grid here basically represents the top of your table, and then up here in the top right hand corner you've got this tool here for easily spinning things around. You can hold down your right mouse button if you want to spin things around, middle scroll wheel to zoom in, zoom out. Lower right hand corner you've got different things you can turn on and off. If you don't want to see the grid, you can click on that and turn that off. You've got options for if you're drawing things or moving things using the ortho option F8, or object snapping if you're again drawing lines, moving things, and then if you right click on that you can choose which snap options you want to have be your default values. And if you are, say for example, drawing something, if there's a different snap that you want to use, you can just right click and it'll bring up all the different snaps that are available. And if we want to open up a 3D file, top left hand corner, IGEMS menu, open, and normally you click on open and navigate to where you've got your file saved. There's also some samples here that you can play with, so we'll start with a fairly simple one here. So depending on how it's drawn, might bring it in like this. So then you can choose how you want to orient it on your table. Cam tab, you've got this align button here. So down at the bottom gives you some different options as far as how you want to align this to your table surface. If I click on this surface here, for example, it'll just lay the part down like that on the table. So the first thing I usually suggest doing is setting the 0, point where you want it on your part. Right now the 0, point is here. Normally we're going to set it at the top of the part somewhere, and usually lower left hand corner if we're just doing a single part. So I can click on the 0 point button here, and since my snaps are turned on, when I come close to an end point, that little red square shows up, and I can just left click and move my 0, point to the top of the part, lower left hand corner. And then we can go through and pick edges that IGEMS will use to project the toolpath depending on what angles that it sees in the part. So to do that, we've got this curves button here. A couple ways of finding those edges. Part like this, easiest thing is probably just click on pick surfaces, and I can click on the top surface and then spin this around and click on the bottom surface, and highlights in red those edges that it finds in the part. And once you got that, just click on done. Shows the different edges that it's found in the part. You can choose additional edges if you need to with these different options over here on the right. And now we're ready to add a toolpath. You can either click on this button here to take you straight to the toolpath area. If I click on close, I can also use this icon here to get to the area where I can add toolpaths. So in this box here, we've got all our settings for the toolpath that we'll add here, working from the top down. Cut type is basically how IGEMS is going to create the toolpath. Normally you'll have this set as ruled, where it'll look at the top and bottom edges that we just selected to determine the trajectory of the stream. You can do a fixed, where you can just give it an angle and you really only have to give it the top edge, and then you specify the angle that you want the cutting head to be fixed at. And then variable uses the top edge and then gives you a lot of control over how that stream goes after it goes past that top curve there. So most of the time you'll leave that as ruled. And then tool position is normally for most sheet cutting going to be set to fix Z. If you're cutting something like a dome or something that's got some 3D shape to it, you can set to follow, and then the Z-axis will move up and down to follow the curve. But most of the time we'll just leave that as fixed. And engagement is what it uses to calculate the feed rate, especially for abrasive cutting. And if you click on this little link here, shows you different images of how the feed rate is going to be calculated. So if you choose upper to lower, the feed rate is based on the distance from the upper curve to the lower curve. As that cutting head tilts over, as the angle increases, then your feed rate is going to slow down as it's going through more and more material. So you've got different options here to choose from. And most of the time you'll probably set that to upper to lower. And then you've got the different piercing types that you can choose from. Most of the time you'll probably just set this to user. And then for the Apex 60, you want to make sure that you have this tilted piercing box checked, and we'll explain that here in a little bit. And then you can specify what you want to use for things like length of lead in, if you want to use any sort of lead out, and if you want to use any sort of overcut to cut past where you let in. And then the checkbox there is for if you want to use the overcut or not. And you got your choice for your 5 different qualities, and then the kerf that we'll look at once we add a toolpath based on the direction that we're going around the cut. So if I click on the auto button and then I left click, it'll use those settings and add my toolpath on there, and I'm just going to hit enter so we can go back and look at this box. The key thing to look at here is kerf. Right now kerf is set to none, so this green line represents the center of my stream. So if we were to cut this, the part would be a little bit, this slot would end up being a bit oversized by basically half the kerf width on each side. If I set it to kerf right, that's where we would want it based on the direction of travel, the green line. You want that green line to be offset into the scrap area. And if we set this to kerf left, then we would end up being oversized on this slot by twice the kerf diameter. So we'll set that to kerf right. If we did want to change the quality, you can click down here and choose a different quality. If we want to use those same settings for the outside, I can click on the auto button again and can left click where I want to add that lead in. So we've got the lead in, and then in this case here we're actually going counterclockwise around this outside cut. You can see this overcut, so it's going to come counterclockwise around this outside cut, cut past where we let in, and then do the lead out. So because we had told it to kerf right on the previous cut, carries over the kerf right and then changes the direction of travel to keep that kerf on the outside of the part into the scrap area. If we want to change our lead position, if we wanted it on the corner here, you can click on this little button here and left click on where you want to have your lead. And then if you want to change your lead angle, so we'd probably want to come in tangentially down this left edge here. This red circle represents that 0.2 of an inch long lead in that I specified, and as I move my mouse around I can determine the angle I want to lead in at. So if I want to go straight into that edge when it locks in at this 12 o'clock position, I can hit enter, and then for the lead out when it locks in at this 9 o'clock position, I can hit enter. And because we're using overcut, it's actually going to come around the corner, which we wouldn't want to do on a corner, so you can turn that overcut off and it'll just lead straight out on that corner there. If I want to change quality, I can come down here, choose a different quality. If I want to do one edge at a different quality, I can click on this little pick button here, and it shows me right now that that cut is in the green medium. So if I wanted to do edge a little bit faster, I can choose different quality, and I can left click and left click and then move my mouse around to indicate which portion of that outside cut that I want to apply the rough quality to. In this case here I want to apply it to that portion of that edge. I left click and that locks that in there. And then if I'm done, I can click on done and then close. If you have a cut that's got different qualities on it, the color of that little icon changes. So in this cut here, this is all at the fines, so it's that little icon is that color. This one changes to indicate that this has multiple cut qualities on it, and then if you click again on that, you can see where those qualities are. If this were a smaller part and we didn't want it to fall into the tank or tip up, you can add tabs on here. You can have a tab at the lead in lead out point. In this case here on the corner, you'd set your lead out length to 0, and then you can check that use overcut box and then put in a negative number to leave a bit of a tab there, depending on how big you want that to be. As you change that, you can see how that toolpath is going to, where that toolpath is going to stop. If I wanted another tab on this cut, maybe on the opposite corner, somewhere over here, you've got this button here for micro joints. You can click on that. Brings up this box here where you can specify the width of your tab and then what you want to use for lead in and lead out for that tab. And again, just make sure you always have that tilted piercing box checked here. Click on add, and then you can just left click where you want to have the lead in lead out. If you want to get rid of that tab, click on delete, and then as you hover near it, when it turns red, you can just left click on it to get rid of it. Once you've got toolpath the way you like it, you can click on the close button. And generally next step will be to adjust rapid heights. You can click on this rapids button here, and right now lifting 1 inch between these cuts. If you want to change that, you can come and click into this box here, click on distance, and then those heights will change. You can also use this height button here, and as you hover over one of the rapids, if you want, you can type in a new number, or you can just visually drag something up and down if you just want to approximate a lift height. Click on default, it'll set it back to where it was originally. If you want to add a stop, maybe you wanted to stop the machine before it did this outside cut, so you could check this first cut. You've got this stop button here, and prompts you to select rapid. So I want to add a stop going from this inside slot to the outside cut, so click on that line there, and then you can either add the stop here or here. So if we wanted to be able to see this slot, we'd probably want to have the stop here so it rapids a little bit out of the way, so you can left click and puts in a stop command, and you can make it either an M00 where it's a hard stop, or M01, it's an optional stop that you'd have to turn on in the controller to actually have it stop at that point. If you want to get rid of that later, you got the little delete button here, and it goes away. And if we think that we've got things the way we like it, you can click on this create part button here, click on file name, it'll pick up the name from the step file. You can specify a quantity for nesting now or later. I usually just set that to 1 and then change the quantity when I get to the nesting, and click on OK. Brings it out into our 2D world. So if you're going to cut just one as your initial prototype test piece, at this point here you'd click on this order button on the cam tab back here in the 2D world. Down the bottom prompts you select cut order parts, so I could just select this part and hit enter. And key thing here is you want to make sure that you click on this part button, and it'll pick up the where we set that 000 point from the 3D area. If you don't do this, then your cutting head is going to end up being too high off the material, because it's going to be basing all the values off of basically the top of the table, and it's going to add the material thickness onto your Z heights. So make sure you click on that part button, and it should show the thickness of your model at this point here. So we'll click on close, and then you can go to your process button, and we can do 3D preview. So for 3D parts, these check boxes here don't apply. These only apply to 2D parts, because the 3D part is going to look at whatever we set for the rapids in the 3D area. So this is an optional box that you can have pop up that allows you to specify things like if you want to use a work offset position, if you want to enter information about your customer, PO number, things like that. You can specify that in this box here. And then we've got information as far as tilt angle and C rotations, rewinds and singularities that we'll talk about here in a moment, maximum Z travel, minimum and maximum X values. And then click on the play button and get a preview of the code. So this is nice to be able to simulate and see what the cutting head's going to be doing. Got the little slider down here if you want to speed it up or slow it down. So we do our pierce, we'll come around and it starts tilting over. We got our little tab that we added on there. So it'll stop, re-pierce, and then continue on. And if we look back in the code, here's that M00 that we put in there, that stop command going from the first slot to the outside cut. Now if you want to make any changes to that part, it's sometimes a little bit tricky for people to figure out when they first start working with this, because their inclination is going to be to click on the 3D 5X button again, which just brings you into open empty workspace. So if you want to make any changes to this part, you double click on the perimeter and brings you back into that 3D area with that part. So if I do make some changes, like I decided that I've cut my first part and happy with things and I want to take out that stop command, can go back to our cam tab, and in this case again the stop commands are under the rapids button, and I can click on delete and it goes away, click on OK. And then to update the part, I would click on create, and update part will update the part. If you wanted to have a new part, so you'd have one part that would have that stop in there, and then a new part that doesn't have it, you click on the new part option. So we'll do update part and OK. And now that will not have that stop command in there anymore. So now we'll talk a little bit about rewinds and singularities, which you have to pay attention to when you're programming the Apex 60 head. So if you're looking down on the Apex 60 head, and these numbers here would relate to the C axis or clock axis for spinning the head around the Z axis. We can go anywhere from positive 270 degrees to negative 223. So those are the C-axis limitations. So when it comes to placing your leads, you want to place your leads in such a position that you're hopefully not going to hit either of these limits depending on the direction that you're going around the cut. And if you are pointing to the left, like the left wall of the tank, that would correspond with a C angle of 0 degrees. And if your stream is pointing to the right as you're standing in the front of the tank, then that would correspond with either positive 180 or negative 180. And if the cutting head or the stream is coming straight towards the front of the tank, then that corresponds with being 90 degrees. And if it's pointing straight back, then that's either negative 90 or 270. Generally, you're going to want to try to position your lead in such that you're pointing towards this either positive 180 or negative 180, and then adjust the direction of travel such that you avoid the limits. Normally you'd set for inside cuts, you would set your direction of travel to be clockwise, and you're going to start at positive 180, and as you're going clockwise around the circle, you're going to pass through 90, 0, negative 90, and then end at negative 180. If you were to say doing a top bevel, as is shown in this image here, and you put your start point over on the right side for this top bevel on this inside cut, you're pointing at 0 degrees when you start, and as you go around that circle, you're going to pass through, if you're going this way, you're going to pass through negative 90, and then you're going to hit the negative 223 area, and then the cutting head will do a rewind. The jet will turn off, it'll spin around, come down, re-pierce, and then continue around to get back to 0. So you have a little bit of a blemish there. Similar things would happen if you start down here at the 90 degree. So if you start down here at the 6 o'clock position and you're traveling in this direction, you're going to go through 0, negative 90, negative 223. Again, it'll hit that point and do a rewind. If you start at this 90 degree and then you go the other direction, it'll go through 90, 180, and then hit the positive 270, do a rewind. So generally said, normally you want to try to position it such that you are pointing to the right, which should give you a positive 180, and then do your inside cuts in the clockwise direction. Similar fashion on a outside cut, if we're doing outside bevel on this part, we'd want to have it on this right edge of that part, which again should put us pointing towards that positive 180, and then work clockwise around that outside cut. And then the other thing I mentioned is singularity, and that's related to the A axis, which is the one that tilts the cutting head over, A like angle of cut. If your C axis is between negative 90 and negative 223, and the A axis passes through 10 degrees, either increasing or decreasing, then you can get a singularity where basically the axes of the motors are lined up, and on the next move the cutting head could spin one way or the other, and you'll get a bit of a ding in your part when it does that. So you want to avoid singularities, and that's why you should always do tilted piercing, because if you start piercing vertically and then the cutting head tilts over, there's pretty good likelihood that you could pass through that singularity point and it'll spin around and ding your part. So that's why you always recommend doing the tilted piercing with the Apex 60. So let's take a look at this part here. So if I double click on it again, bring it back in. So right now we didn't have any sort of singularities on this part. So on this part here we are at 0 degrees and we're tilting over to 30 degrees. We didn't get a singularity because as it was tilting over we were basically pointing towards C of 0, and then when we're coming this direction, same things. But if I rotate this part, we should be able to get a singularity here. So if I go to my cam tab, and on this align submenu, can click on rotate, and we'll try going negative 90. So here as it's cutting along this direction, the cutting head will be pointing towards the back of the machine, so that should be C of negative 90, and we'll be tilting through that 10 degrees on the A, which should give us singularities on each side here. So we'll go ahead and create the part, and we're going to do a new part. So original part on the left, new part here on the right. We want to set our 0 point again, and make sure you click on that part button to pick up the 0 point from the 3D area, and we'll process it. This time it wants to know which one we want to process, so click on this dotted line here to tell it that this is the one that I want to work with, and see what the simulation shows us. So we got 2 singularities and shows you what line in the file it is. So as we scroll down here, so coming along this edge, our C is at negative 90, and then the A is going smaller and smaller, or sorry, larger and larger, passes through 10 degrees. We'll have a singularity. The cutting head will spin around there and probably give us a ding on the part. And then after it re-pierces after that tab, going up the other side, again here the A is decreasing and passes through 10 degrees with the C at -90. So just want to be careful about that. And that being said, if you do have a part where you can get singularities like this, then when you nest it, you want to make sure that you set the rotation to none, because you don't want the nesting to rotate this part and then give you singularities. So to set that rotation, on Cam tab, Parts submenu, Properties, you can click on the part, hit enter, and you can change your default rotation step to be none. And then that way when you nest it, it won't get spun around and give you singularities. So let's go ahead and nest this. So we'll just nest 10 of them. As you can see, the rotation step is now none. And we'll just give it a sheet size here. Actually change my start corner. Stop and OK. So they'll all be in the same orientation as the original part. And key thing when you nest 3D 5-axis parts, when you do the order button for the sheet, rather than clicking the part button, because if I click on the part button, it's going to move my 000 point to the corner of that part. Ultimately, we want it on the corner of the sheet. So let's just undo what I just did there, Control Z. So let's set our 000 point again here. And rather than clicking on part, if it's a nest, what you want to do is click on this 2D 3D button and use the thickness that we had, or the Z value that we had just from the individual part. So one way to do that is actually initially just click on the part. You can highlight this and copy that, Control C, and then use this pick button here to move that 000 point back to the corner of the sheet. Click on the 2D 3D button, and then you can Control V, paste that value back in there. So if we go down to the bottom here, got no rewinds, no singularities on that entire nest. That's good. So if you were to forget that step as far as changing that Z on the nest, I have built a warning into the post processor. So if I just were to click close at this point and then go and process it, you will get this warning here, check 000 position. Either you've got your 000 position in the wrong location on the 3D 5X part, or when you did the order command you forgot to move it to the top of the part. So that's a little check there that I've built in. So you would then of course go back in here again and click on this and plug in that thickness. So now let's take a look at rewinds. So I'll grab a different sample here. I'll grab this one. I can also show you how to draw on some construction lines if needed. So a part like this for this inside bevel cut here. To do this as one continuous cut, we could add in some construction lines rather than here we've got these broken edges. So you'd have to do it as 3 separate cuts as it is right now. But on the CAD tab, we've got some tools that allow us to draw in some lines and things if we need to, some construction lines to work with. So I'll use the circle command here. It's a 3-point circle, so if I pick 3 points along this top circle here and then hit enter, do the same thing on the this area here. So pick 3 points. And now that we've got that, then we can go ahead and pick some edges. And other thing to note on this model here is it's floating off in space. So on our cam tab, you can do the align like we did before, or you can also use this Z height button here. Right now the bottom is 0.197 off the table, so we just change that to 0. and that's another way to get your part position where you want it on the table. And then move our 0 point, so we'll do the 0 point command and stick that at the top of the part, lower left hand corner there. And then we'll go ahead and click curves and pick edges, and we'll choose that as one edge, and then we'll choose this as the other edge that we need for right now. We'll come back and do the vertical cuts later. So now I've got that, can go to our toolpath area and see what we got for settings here from before. Length of lead in, we're not going to be using any overcut. Yeah, we'll use overcut on this here, so we use overcut. And we'll go ahead and set this to be curve right. Click on our plus button, upper curve, this one will pierce here. Gonna hit enter because we're gonna go all the way around here. We'll go clockwise and then choose our lower curve and do our lead in and lead out there. So we'll go ahead and just close, and rapids, we'll adjust our rapid heights. We'll just do a little lift there, and then create part, click on file name, click on OK. There's the new part. So set our 0 point, make sure you click on the part button, close process, and here we see we have no rewinds, as I would expect, because we are pointing at the beginning here, pointing at C of 180, and then since we are going clockwise, the C value gets smaller and smaller, and at the end of the cut we end up at negative 180. However, if I do rotate this part, or if when I was in 3D5X I'd put that lead in the wrong place, I'll just do R for rotate, and we'll just rotate this 180 degrees, and then just set our 0 point again here. So now we got a rewind, shows you what line it's at, and so now we've got the C starting at 0 and it gets smaller and smaller, and then once it gets to around 223 it'll do the rewind and then picks up again. We've got a little bit of a buffer on that negative 223 number, which is why this one stopped at 213. So that's rewind. So again, to fix that, if my part were already programmed in this orientation, then I could double click on there and change the part in 3D5X. Of course, this is the original orientation of that part. But if I rotate it in here 180, so this orientation would give us that rewind, then I would come in and again use this pick button and put my lead in somewhere over here and avoid that unwind. And since we're here, we'll go ahead and program this vertical cut. This is kind of a interesting one where that cut is going down below the surface of the part. So we'll go to curves and we can pick edges. So sometimes on these more complex ones it's easier to do the pick edges option. So I can either just click on the next line or down here at the bottom end on your keyboard, or just click on next and it'll find the next, what it sees as the next little line segment in the model. And in this case here, it's seeing this one here. If you don't want to go in that direction, we actually want to go in this direction. I can click on that line to send it in the right direction. And here we don't want to go that way, we want to go this way, so I left click on that and then keep doing that end command. And here again we want to go this way and left click on that. And if you do end up going the wrong way, like I did here, down at the bottom, you can just hit the backspace key and then send it in the direction that you actually want to go. Click on Done. Now, since this cut is going to be a vertical cut, I really don't need to choose a bottom edge. So I'll show you how that will work. You could choose the bottom edge if you wanted to, but for vertical cuts you really don't need to choose a bottom edge unless for the speed calculation you need that for the engagement. So we'll click on our Add Tool, and we'll click on our plus button, select upper curve here, and then where we want to pierce, we'll go ahead and pierce the same location we're doing the bevel pierce. Endpoint, hit enter, direction of travel, and then lower curve. Since I didn't select a lower curve, I can just hit enter and then give it the lead in and lead out information again. Now in this one, the engagement is set to upper to lower. However, since I didn't choose a lower curve on this, that's not really going to give us valid speeds. So you'd want to change this, in this case, to constant. And then if you don't know the thickness of the model, you can click on this little point here, and you can click 2 points here, and it'll pick up the thickness of the model, and it's going to use that as your feed rate on that cut. So on this cut here, we had it set to upper to lower, so it's going to calculate the feed rate from this upper edge that we selected down to this lower edge, which will be alright. We're cutting through some additional material down here at the bottom, but it's in the scrap area, so that's really not going to affect our speeds that much or need us to change that speed. If you did want to cut slower to account for cutting through the entire thickness of the material down to the table, you could switch this to upper to table, and then those red lines you see extended down, and that's the additional distance that it would use to calculate the feed rate. So it would cut that a little bit slower, because now it's looking at cutting through that entire thickness of the material. But again, since this is pretty much scrap area that's going to be cut off anyways, you could just probably keep this as upper to lower. And then we'll go back and just do our edges for the outside. So and again, since that's just a vertical cut, I'm just going to go and choose that top edge. So plus button, and where I want to pierce, end, and then direction of travel. And lower curve, I'm going to hit enter, and lead in and lead out. And we don't really need any overcut. Might want to give ourselves a little bit of lead out. And make sure we get the kerf on the correct side there. A couple other things to talk about in this box that we haven't talked about. Down here at the bottom, you can choose to turn on taper angle control. So this will tilt the head slightly to adjust for a slight bevel that you might have on the Waterjet cut. As you go faster and faster, you'll have more taper top to bottom, and the taper angle control, turn that on here. It'll tilt the head slightly to adjust for that. So you can apply that per cut. So if you want to do that on all the cuts, you can. You can even do it on the bevel cut if you want to apply that. So these TAC numbers come from your material database. If I go into my select icon here and edit my material and scroll down here a little bit. So generally for most of the materials you already have some values in here. If you've got a new material, you can basically cut a little piece like this at the rough speed and the extra fine speed and make these 4 measurements on the part A, B, C, and D and plug them into here. And A and B and C and D are subtracted to give you these TAC, taper angle control numbers, that it's going to adjust for. And then the other thing that IGEMS does that's pretty cool is this VOC thing, variable offset control. As you cut slower, your stream width, your kerf width is going to get a little bit wider as it eats away more and more material. And the VOC will actually adjust the toolpath slightly as it comes into a corner and slows down to the low speed, and that kerf width gets slightly wider. The VOC will adjust the toolpath slightly for that, so that's what the VOC is. So So if we go back into our toolpath area, if you did want to use also VOC on the cuts, you could also select that per cut here. And then lag is a similar thing to TAC, where you can choose that to tilt the head forward slightly to adjust for the stream lag. So we'll go ahead and adjust our rapids. And then we'll go ahead and create part. And set my 0, point. And then if we actually want to use the TAC and the VOC that we turned on in the 3D5X, you also want to click these boxes here to turn those on. If you always want to default to those being on, click on the gear, click on strategy, and in the cutting area you can set these to always default to being on with the option to turn them off. So no rewinds, no singularities. And we'll see on this cut here, this was 45 degrees, but with the TAC turned on, calculates that as being 41.88 degrees. And then on the vertical cut, you can see we have a slight A angle there to adjust for that taper. And same thing on the outside cut. Next thing I'd like to touch on is the programming of the height setter. If we go back to this video here that we saw initially, brief clip of, Apex 60 has a initial height setter built into it that we see here. We'll come down, find the top surface of the material to establish your standoff distance. So it's particularly nice if your material is not very flat. You can have it touch off, and there's different ways that you can, or different strategies that you can use to apply that. You can have it touch off just on the very first pierce of a nest, you can have it touch off on the first pierce of each part, or you can give it a radius, and once it gets outside of whatever radius that you've specified, it'll do another height setter routine. So far, any of the programs I've shown you have been using programmable Z up and down. If you want to switch to using the height setter, that's a setting. You can click on this little gear in the process area, go to strategy, and on the settings area you've got the choice between fix Z, CNC controlled, or by height sensor, and then you can choose either sheet wise, again that would be just on the very first pierce of a nest, which you'd only want to do if your material was really flat. Part wise, where it'll touch off on the first pierce of each part. And then stamping, where once it gets outside, in this case a 12-inch radius from the last time that it did a height setter, it'll do another height setter. So if I take a look at this part here now, we've got one height setter on this part now at the very beginning. It should always do it on the first cut. So we'll come over, rather, before we had a G00 to come down, now we've got this M402 command which triggers the height setter, and then that reestablishes our new Z0 height based on where the height setter finds the top of the material. So you can adjust how many height setter it does with those various settings, the sheet wise, part wise, or the stamping radius. You can also force it to do a height setter on a particular cut if you really want to make sure that you're at a particular height for a cut. So I'll just do a part here like this, and I'll just do quick, but I'm just going to delete all those and take this into 3D5X through this bevel option. So let's go ahead and add a bevel cut on here. We'll do a bevel cut like this. On that cut there. And we'll just go with that. Click on close, do curves. I'll pick surfaces, which will get those. And then for that edge in there, I'll have to go in and select that with edges. And for next, gives me that. So if I go to toolpath, and we'll go ahead and add a toolpath. I'm going to switch this back to upper to lower. So we'll add a toolpath on here. And so since that's the first cut, should do a height setter there. And then if I wanted to make sure that it did a height setter on this bevel cut, then we would add our bevel cut. And under attributes, we have this HS option here, which when the post-processor sees that code, then it's going to trigger the height setter to do the height setter routine on that cut. And then we can add our cut for the vertical cut. So if I want to use the same settings, click on the auto button, and again click on our pierce point. We'll carry over that height setter attribute from the prior cut, which in this case we wouldn't want to do a height setter because we've already cut that bevel cut and there wouldn't be anything for the height setter to come down onto, so you can just switch that just to be blank. And then from there we can use the auto button on the other cuts. So we've got the height setter attribute on that one. Close that. We've got our 0, point at the top of the part. Set our rapids. And create. And set our 0, point. Click on part. Process. And now we've got two height setters. So it'll do it on the first one again, as it should, always on the first cut, and then also on that bevel cut where we had added the height setter attribute. Next, we'll take a look at the flip windup option in 3D5X. Sometimes this can come in handy if IGEMS chooses the wrong value for your C starting angle. So if we refer back to this example here, for example, pointing in this direction, it can choose either -90 or 270. So depending on the direction, it might choose the wrong one, and the flip windup can be used to choose the alternate solution. If we take a part like this, this would be parts being cut out of foam, and we'll just program this bevel cut here. So before I forget, I'll go ahead and set my 0, point where I want it, and we'll go to curves, and I'll pick edges this time, and we'll hit enter and pick edges again, pick that, and we want to go that way. That gives us all we need. Go to our toolpath area, and I'm going to be going in this direction, so I'll set curve right, click on the plus button, upper curve, start point, end point, and then click on this for a lower curve, and then give myself a little bit of lead in and lead out. Engagement, usually for water only cutting, we'll just set the engagement to constant. So unlike abrasive cutting, you usually don't have to worry about the engagement, because usually water only cutting you just cut at one fixed speed. And click on OK, and we'll just adjust our rapids. Being water only, you could probably just set your rapid heights to 0, since usually you don't have to worry too much about collisions with water only cutting. And then click on create, and set our start point. Make sure we click on our part button, and see here we have a rewind, and basically at the very beginning of that cut at the pierce point is choosing C of 270 instead of the C of -90. Then once it starts the cut, it goes to the C of minus 90 because it's getting essentially going in that direction where it can't go any further past 270, so it switches it to the C of negative 90. So that's where the flip windup can come in handy. So double click on the part again to edit it and go back to our tool path, and down here at the bottom you got the flip windup checkbox, create update part, and no rewind. And now we're starting at C of negative 90. And I think the final thing we'll run through today is how IGEMS can create a fixture from a model. Let's take a look at this sample here. We could assume that maybe your customer had this part already bent and then they realized that they forgot to cut this slot in here or something like that. Given the shape, might be kind of hard just to lay down on the table to get it in a good orientation to be able to cut that. So in IGEMS you can create a fixture to support this, locate it, and make it a little bit easier to work with. So let's see what our bottom of the parts right now. The bottom of the part is 1.5 inches off the, or 1.6 inches. So if you need to or want to, you can move that up or down as needed. And once you've got it in a location that you like, so we could rotate it if we wanted to. And then on the Tools tab, you've got this grid option here, and you can go through and create a fixture to support this. So you got your stream diameter here, thickness of the material that you're using to create the fixture, quantity X and Y are the fins that are in the fixture, and you can also click and you can move these around if you need to. And then you've got offset of the base, so if you want to make that base a little bit bigger, you can change those numbers. This offset number here, let me click on calculate so we can see what we've built so far. This offset number here is related to the basically the web around these slots here. So if you want to give yourself more meat around there, you can adjust those numbers. You can adjust the length of the slots. So it's going to make this tab and slot fixture that you can piece together. And then you've got also options for these clamps, or if you want to have these sticking up to help position the part, you can choose to have the clamps inside and or outside. But if we're going to be cutting this slot here in the middle, we wouldn't want the interior clamps. And then you can adjust these numbers and kind of just play with these numbers until you get something that looks like what you need. So it's pretty handy tool. And then once you got something that you think will work for you, you can go ahead and click on export, and this puts the 2D geometry out here in the 2D world, so you can cut this later out of whatever your fixture material is. It's got the letters and numbers on there to correspond with the location of these pieces in the fixture. So Y1 would go in this slot here, Y2 would go back here, and then X1 and 2 go left to right. So you just hit enter and it will bring you back into the 3D area. So the good thing about having a fixture like this now is that you can more accurately set a start point, a 0, 0 point on the fixture versus trying to pick up a point maybe on the part, which this part maybe might not be so bad, but if you've got a part that's all curves and doesn't have any square corners, having the fixture with a square corner, you can go to your cam tab, pick 0 point, and put your 0 point at the corner of the fixture. And then from there we could go ahead and pick curves. So I'll go ahead and I guess we'll do edges. And we'll follow this around. And we'll go ahead and pick the lower edge also. I think this is basically just a vertical cut. Oh, went the wrong way, hit backspace. That's good. We want to go this way. So click on Done, click on Close, Toolpath. So this time we're going to switch to be Follow, so our toolpath will follow the shape of the part here. Engagement, we'll set that upper to lower. And we'll click on plus and choose where we want to pierce. So upper curve and then pierce point and direction and lower curve and lead in and lead out. So this standoff height here, you just change that to 0. That was left over from the previous part that we just did. This standoff can be used to give yourself a little bit of leeway, so if you're not quite sure how close the model matches the actual part, if you want to cut a little bit further away from the part, you can add additional standoffs. So if I put 1/8 inch in here, that would add an 1/8 inch to the normal 1/8 inch that we're off our material, so we'd end up being about 1/4 inch off the material when we cut this. And then if you feel comfortable with things later on, you can drop that down some. So that's what the standoff can do for you. And that all looks good. And we can go into rapids. So this rapids, you can also do things like adjust how you approach this cut, and at the end of the cut, if you want to wrap it away out of the way, so you can, maybe you got a bunch of these that you have to cut this slot out of, you can modify your rapids so at the end it just gets out of the way. So click on modify and choose the rapid that we want to modify, which would be this one here, which is at the end of the cut, because this one is for the lead in. Click on this. So first we can tell it basically go vertical and tell it how many inches that you want to lift up vertically, and turn on my ortho. So if I wanted to lift up, say, 2 inches, and then go to horizontal plane, and I want to go back 12 inches or something, get well out of the way, hit enter and done, and then click on OK and create parts. So we've got these pieces here that we can cut out of our fixture material, and then the actual part that we'll be cutting. And click on our part button, so it sets our 0 point up there to correspond with that corner of the fixture. And then this might be a nice application where, rather than doing G92, where all your coordinates are based off of wherever you start your program, so rather than doing G92, we could choose G54 work offset position. All the coordinates are based off of the G54 saved position in the controller. Therefore, you can basically start the cutting head wherever on the table. So basically, instead of having a G92 X0, Y0, Z0 at the beginning of the program, we now have this G54. Controller looks and sees what the saved G54 coordinates are, which would be the back left hand corner of this fixture here. And then at the end of the program, it's going to wrap it up, wrap it back to that point there, take this part off, clamp the next one down, and then when you hit start, because we are doing the G54, it's just going to wrap it back to the right to the pierce point. So it's going to skip this rapid. It's going to come right from where it finished right back to where it started and pierce and continue. So G54 is nice if you're doing a lot of repetitive work on this on a fixture. You don't always have to move the cutting head back to the start point again and again. Now this is putting a little bit of A and C motion in there. If this is supposed to be just a vertical cut, I'll show you one thing in here you can change. So we go back to our toolpath area. Down at the bottom you have this 3-axis cutting option. So then that will ignore any tilting of A and C. So I think that about does it for today. Let's see what questions we've got.